Hello everyone. Can anyone confirm that my screen is visible and audio is clear or not? Okay, fine. Uh, let's start the session. Uh, this is the fourth tutorial session of this course network analysis. Whose instructor is Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur, and I am Satya. I am PMRF research scholar at Department of Energy Science and Engineering, IIT Bombay. In the last tutorial session, we have studied few of the topics and problems related to the differential equations, and also we have solved few of the problem, which was mainly for solving the assignment number 3. So in this tutorial session, we will see the few of the questions which will help you to solve the assignment 4 and assignment 5 particularly. And also, means the first part will be solving the phasors and all, and the second part will be related to the mutual coupling and self-inductance and the mutual inductance kind of questions. Okay. So for starting the questions, let me put the first question before you. Okay. So I'm giving you a few minutes to solve this question. Just let me know if you got the answer. In this question, it was asking the voltage VL phase angle. This voltage VL phase angle, and that too with respect to the VS. Okay, take care of this thing. Which reference it is asking. Try to use the voltage division rule here. If you are saying with respect to the VS, then try to find out with respect to VS only the value of the VL and all. You don't need to know the VL magnitude because it was asking the phase angle only. Okay, let me give the solution for this problem. Uh, what is the question is asking the phase, the voltage VL phase angle. It is asking the what is the angle of VL. Suppose this is theta L, and it too with respect to VS. It means that if you are considering VS angle 0 degree, so the phase angle between the VL and VS, it will be a theta. Okay. So how to calculate that? Okay. So first step is to remember the what is the voltage division principle. Suppose this is the one circuit, and this is the suppose you have uh, Z1, and there is another element is there Z2, and there is a one source is connected. Suppose this is the VS. Okay. So if there is a voltage drop across the Z1, suppose this is a VZ1, and across Z2, it's a VZ2. Okay. And this is VS. So the VZ1 by the voltage division principle, it will become the Vs times of Z1 divided by Z1 plus Z2. This is actually the voltage across the Z1. And if you see across the what is the voltage across the Z2, it will be Vs Z2 divided by Z2 plus Z1. Okay. So this is the voltage division principle in the circuits. What is the step two? Step two is the applying this principle into the circuit. So it is asking what is the voltage across the 10 J10 ohm. That is simply it is asking what is the value of VA. So if by the same principle the value of VL will be equal to Vs times of J10 divided by 17.32 plus J10. Okay. So if you convert into the phasor terms, it will become Vs. Suppose Vs, I am considering Vs angle 0 degree. Okay. So the because we have to take the with respect to Vs. So let's assume that its phase angle is 0. Okay. So what the magnitude it will come? It will come out to be like this: 10 root 17.32 of a square plus 10 of a square. Okay. What will be the angle? Angle will come out to be, suppose I am writing here theta. So theta will come out to be angle 90 degree in the upper part and divided by the tan inverse angle at a tan inverse of 10 divided by 17.32. Okay. Or you can write in terms of like this. Theta will become 90 degree minus tan inverse 10 divided by 17.32. Okay. If you solve it, it will come out to be minus 30 degree in the denominator here. It will come out to be 30 degree and here 90. So it will come out to be 60 degree. It means that VL will come out to be VS and some magnitude terms of VL. Suppose I am considering at X and some angle at 60 degree. Okay. What we have seen, we have taken the VS as a reference, that VS angle 0 degree. So now it is coming 60 degree leading. This VL is 60 degree leading. Okay. So now the answer will be the 60 degree here. Okay. Any doubt in this? Anybody? So just I have used the simple principle that the one circuit is given here and one coil is there and Vs we have applied and we are finding the what is the voltage across this VL and this is the let me see there. This is the 17.32 and this is the J10 and this is Vs given. Okay. So what I am finding VL. VL is equal to Vs times of J10 divided by 17.32 plus J10. Okay, so simply Vs, what the angle will come, Vs and magnitude Vs, and this will become 10 divided by root 10 square plus 17.32 square. If you're taking Vs angle 0 degree, the angle will become 90 degree minus tan inverse 10 by 17.32. Okay, this is a simple way to solve what is the angle of VL. It is there with respect to Vs. Okay, that is 90 minus tan inverse 10 by 17.32. Okay, let's go to the second part because I'm giving you this kind of question because it will help you to solve the assignment 4. Okay, in the last we have the question related to the mutual and the self inductance also, which will help to you to solve the assignment 5. Okay, let's move to the second question. Try to solve this part.
Sir, could you explain the previous problem once again?
Okay, yeah, sure. So let me take the question again. So the question was such that this was the question that, and let me draw the circuit first. Okay, and this is the R value. R value is given as 17.32, and this was the J10. Okay, and this is the VS is given, and this was the VL. In the question, what is asking, what is the phase angle? Phase angle of VL with respect to VS. Okay, so let's assume that the angle of Vs, because we have to take the some reference to find out to what is the phase angle of VL. Okay, so let's assume that Vs is the phase angle at it is at 0 degree. Okay, and we will find out what is the phase angle of VL. Use the voltage division principle. VL is equal to Vs times of Vs angle 0 degree times of J10 divided by J10 plus 17.32. Okay. Then in the terms of magnitude and phase, what you will be writing this 10 underscore 10 of square plus 17.32 of square, and the angle will become tan inverse 10 90 minus tan inverse because the upper part j is there. 90 minus tan inverse 10 divided by 17.32. Okay. So what will be the phase angle? Suppose this term, I'm assuming that this is a x. Okay. So this will magnitude will become mod of x, and angle will become 0 degree plus 90 degree minus tan inverse 10 by 17.32. When you solve this, it will come out to be 60 degree. It means that Vs was already at the reference 0 degree. The VL will come like this. VL some magnitude. This is equal to Vs times of mod of x, and this will be a 60 degree. Okay, so the same thing it is asking in the question itself, that what is the phase angle of VL with respect to Vs. If Vs is at 0 degree, it means that it is leading with respect to Vs at 60 degree. Okay, I hope you have got the uh, point. Huh? Let's move to the second question. Solve this part. If you feel like you are not able to solve or you need any hint or something, just let me know by opening your mic or writing in the chat box. So, okay, I got one answer as 15 amps. Okay. Anybody else? Try try to solve with respect to the phases, because the circuit elements are different. You cannot just add or subtract this current. See in terms of phasor. Anybody else? No. I got only one answer till now. I request everyone to solve it. Okay, let me give the solution for this. Uh, let's analyze the circuit first. Okay, what it is saying that there are different emitters are there. Emitters means to measure the currents. Okay, and these emitters measure that the current through A2 emitter it reaches the 12 amps. It means that the 12 amp current is going in the magnitude terms. Okay. And the A3, this emitter 3 reads the 9 ampere current. It means that 9 ampere magnitude is going into the A3. So it is asking that the emitter A1, what the current it will read. Okay. So let's assume that we can directly find it out, but let me go by the step by step. Okay. Suppose this is the voltage Vx here. Okay. And I'm taking a reference as here to find out what is the voltage there. Okay. So the current going into the IA3 will be equal to Vs Vx divided by Jx. Suppose this is the X reactance is there, Jx. Okay. What about the A2? The A2 will be Vx divided by R. Okay. So if you draw in terms of the phasor, I'm not concerned about the what is the magnitude. I'm concerned about where it lies in the phasor. Let's take the Vx as a reference. Okay. If I'm taking Vx as a reference, Vx angle 0 degree, so the current IA2 will lie in the same line because this is also angle 0 degree. So resistor is there, so it's a magnitude drop is there, but the phase angle will remain. So this is actually the Vx by R. What about IA2? This is actually IA2. What about IA3? If you solve this, this will become Vx by X. Vx was angle 0 degree and Jx was angle at 90 degree. It will become minus 90 degree. Okay. So it means that it will lie somewhere else, somewhere like this. Vx by x, okay, and angle minus 90 degree. Minus 90 degree means it is lagging with respect to Vx by 90 degree. Okay. Minus means you always take in the anti-clockwise direction. Okay. Now this is become IA3. What about IA1? IA1 is actually is phasor sum of means magnitude of IA2, angle of IA2, theta of IA2 plus IA3 plus angle of theta IA3. It means that it is not just lying on the same plane, because if two resistors are there, suppose this is the resistor, if we draw the phasor of this, suppose this is the Vx across that, the current which is flowing here will be the same current flowing here, okay? And it will lie in this phasor only. Suppose this is that, so this is the R1, this is R2, so that will become Vx by R1 and Vx by R2. So you can directly add both. Okay, the current will be the remain same for these two. It means that if the magnitudes are same, it means that it will lie on the same planes. Okay, so it means that here the inductor is here, so it is lagging by 90 degree. Okay, so how to add these two? So now for the adding both terms, you know the I net equivalent, what it will look like. It's this will be IA2 square plus IA3 square plus 2 times of IA2 plus IA3 cos of angle between them. Okay. So here the cos 90 is there. Cos 90 because the phase angle between the both are phasors are 90 degree. Okay. So it will become 0. So this term will not come into the picture because the cos 90 is 0. So what will be the magnitude here? IA2 it is already there. What is this? IA2 is 12 square. What is the value of IA3? It is given 9 square. When you solve this, it will come out to be 15 amps. Okay, because this is a 144 and this is the 81, it will come out to be 5225. So net comes will be the 15 amps. So 15 amps current in the magnitude terms it will come here. Okay, I hope you have got the answer. Okay, any doubt in this? When you see the register terms, okay, then you are saying something.
Sir, how do you take the angles, sir? 0 and minus 90, those things.
Okay, let me give you the reference. So what I have done, I have considered that this is the one circuit and this was the one circuit is there. Okay. So something was connected here, some emitter A1 was connected and some source was there. Okay. So what I have done, I have taken this Vx as a reference. Okay. And I can take that because anything you can take as a reference, but you need to ground somewhere. Okay. I have taken this at a zero potential and so it became the Vx here. Okay. So the current, if the circuit element is like this and this is grounded and this is the Vx, so what amount of current it will flow? That simply the I current will be Vx divided by Jx. Okay. And similarly, if you see the resistor is there, so the current which will flow I will be equal to V by X. So now if you see in the V by R, okay. So now you can see that the magnitudes here are here mod of V by R, but it is something at an angle of 0 degree. How 0 degree? Because R don't have any phase angle, but V do have. Why? Suppose I have taken a reference Vx is equal to mod of Vx angle 0 degree. Okay. I don't know the value of magnitude, but I am taking it as a reference. So register don't have any phase angle. So overall it become V minus mod of V by R and angle 0 degree. What about this inductor? The magnitude will be like this Vx by X. What will be the angle? This is angle 0 degree. Here the J term is there. J terms means it is at angle of 90 degree. So if you take it at the denominator, it will become minus 90 degree. Okay. So now from here, the phase angle I have defined. I have taken this Vx as a reference 0 degree. So the current is in the same angle, means this is the rotating partner. It will rotate till 360 degree. Okay. So it was at the same level, whatever the level was at Vx, I mean the angle basically. So that's why I'm taking the, because it was lagging. Okay. So it lagging means it was means behind the Vx by 90 degree. So it was actually the Vx by x magnitude. Angle was 90 degree. That's why this phase angles comes that 0 degree and 90 degree, taking one value as a reference. It means that you cannot just directly add both of the terms. You can add the terms which are at a same phase angle. So this is a I1, this is I2, this is I3. So you can directly add these terms that I is equal to I1 plus I2 plus I3. But if you get this I4, you cannot directly add these two values. You have to take the net value. Suppose this is the I net. So then you have to use the that rectangular Cartesian formula, I net square I4 square plus 2 times of I net I4 cos of angle between them. Cos of angle between the I net and the I4. Okay. This you have to take care in terms of the phases when you have the different elements are connected. Okay, I hope you have got the point. Huh? So let's move to the third question. This is a one question which you have to take care of the few things here. Just try once. I will give you the solution after that. Some hint is like this. There is a one junction is there and some current is flowing. Suppose and it means that okay, they are saying entering. It means that I1, I2 and I3 is coming to the node. Okay. So this is the node. This is junction and these are the currents which are entering. Take it as a hint. Anyone? Take your time to solve. Huh? There is no need to hurry. Okay, yes. This saying I don't know how to solve this question. Okay, okay. Let me make you understand this kind of problem. This is basically simple problems related to the phases. Okay, phases means let's take few of the minutes to first understand what is a phasor actually. So in the polar terms, you have seen few of the terms like 3 plus 4j kind of, or 6 or 5 plus 2j kind of, or 2j. So these are the polar coordinates, sorry, rectangular coordinates. Okay. So if you try to solve and convert into the polar forms, so it will be represented something like this. Some magnitude will be there x and angle of that theta x. Okay. So this is basically converting from one coordinate system to the other coordinate system. Okay. And this makes the thing easier. Why I'm saying that? If you see this 3 plus 4j term, suppose this is a x is equal to 3 and this is the 4. So if you see, draw the phasor of this, so it will look like something this 3. So some magnitude will be there, that is the root 4 square plus 3 square, and some angle that is tan inverse 4 by 3. Okay. So how to convert into a phasor form now? So what I do, I take some of the values as a reference. Suppose I have taken the x as a reference. So it's 6 here. So 6 will lie here. So 6 here. 6 will lie here. So 6 angle 0, it will be represented as, because there is a no j term here. So 6 angle 0 degree. If I've taken this, suppose this is the x. So x was the reference. X was at a tan inverse 4 by 3. Now it means that it is at 0. It means that it will lie somewhere here, like 0 here. It means because it is leading at an angle of 4 by 3. Okay. So you always try to take one of the as a reference. You can take the 0 as a reference also. You can take the tan inverse 4 by 3 also as a reference. So if you add in 0 plus tan inverse 4 by 3, then you will get this phasor, the tan inverse 4 by 3. Same in the here polar also you can see. In this as a 0 reference, when you add 0 plus tan inverse 4 by 3, then you will get this value, this at a phasor. Magnitude could be anything. It will be x, y, z, anything. But the polar, this angle you have to see. Okay. Let's see from the this question perspective. In this question, what is saying that there is a one junction is there. One junction and the three currents are coming. That is I1, I2, and I3. Three currents are here. So according to the KCL, at a junction point, KCL, at a junction, summation of I will be equal to 0. Okay? Simple rule, simple KCL equation. It means that I1 plus I2 plus I3 will be equal to 0, and I3 will be equal to, it is asking what is the value of I3. I3 will be equal to minus times of I1 plus I2. Just put the value of I1 and I2 minus times of I1. I1 is minus 6 sine omega t plus 8 cos omega t, and this is in the terms of milliamps. Okay. So it will come out to be 6 sine omega t minus 8 cos omega t. Okay. So always remember that when you're adding the two values in the phasor, the omega will be always same. This rotating part at the angle it is rotating, it will be always constant. If you see you can add subtract the phasors only when this omega will be the same. Okay. If you see in these two parts, 6 sin omega t and 8 cos omega t, the omega t is constant. You can add, subtract in the phasor terms. Okay. So let's draw the curve of these two. Cos usually start like this. Cos here, if it is a omega t, and this cos will be move like this. Okay. So this is the cos term, and it will cut here 90 degree and minus 90 degree. But in the question, if you see, this is the minus cos omega t. So minus cos omega t will be look like this. Okay, its magnitude will be minus 8, maximum value. What about sine? Sine start from 0. Okay, it will start from 0 and it will move like this and it will move like this kind of. Okay, so now the two concepts are there. Concepts are leading and lagging. How to see from the curves itself that which term, which equation, this is the one, 8 cos omega t minus 8 cos omega t term is there, and this was the 6 sin omega t, which is actually leading or lagging. Always see that when the angles are increasing, suppose this is the curve of the sine, let me take another color here. So if you see from here, the sine is actually values are increasing and then decreasing here. So in this region, it is actually increasing. Okay. And if you see in the terms of if in terms of cos also, this is increasing. Here, if you see, this is actually increasing cos. So lagging and leading will be defined in terms of the when it is increasing or when it is decreasing completely. Okay. So suppose two curves are increasing like this. So the phase angle at the right side of the x-axis when it cuts, then you can see the what is the difference between the both rotations. If you see here, the both values are increasing here, and this will be the angle between them. Means 6 sin omega t is actually lagging behind the minus 8 cos omega t. Getting my point? Means when you increase the 6 omega t, the minus 8 cos omega t was already been appeared at the point of 0 here, 90 degree here. It means what you can say from this equation that 6 sin omega t is actually lagging behind minus 8 cos omega t. Okay. So if you take the 6 sin omega t as a reference, means this is at the angle of 0 degree, then you can represent minus 8 cos omega t as leading at an angle of 90 degree. Getting my point? It means that lagging leading concept. Suppose this is the 6 sin omega t and this was the minus 8 cos omega t. Suppose I take the 6 sin omega t as a reference. Suppose I am taking it as a 0 degree. Okay. So it means that minus 8 cos omega t is already been happening at a 90 degree. It means that it is leading. Okay. So how to represent this in the phasor term? Take the magnitude. Take the magnitude at 6. 6 I am taking maximum values basically. This is maximum value. So 6 angle 0 degree. So what about this? Minus 8 means cos omega t. It will be equal to minus 8. Minus 8 we have already taken. Minus 8 angle of 90 degree. Okay. You can directly add these two. 6 angle 0 degree minus 8 angle 90 degree. Okay. So what you get in terms of the magnitude terms? Magnitude you can directly add, it will be like this 6 minus j8 something. So if you solve this, you will get 10 magnitude terms, and in the phasor terms, you will get minus of tan inverse 8 by 6. If you solve, you will get something. This is the 4, this is 3. You will get 56 point something angle. Again, by converting again to the sine terms, what you have taken as a reference, you have taken the sine as a reference, then it will come out to be sine omega t minus of angle which was taken as a reference because it was minus. Okay, let me explain it again. I hope means it will create it some difficult understanding first glance, but it will become habitual when you solve the questions and all. Okay, let me again solve this and make you understand. Suppose I am taking some different phases. Suppose I have taken that this is a cos, and this is a sine. Okay, something like this. So this was the 0 degree, and this was the 180-degree kind of, and this is the 90 degree. Okay. So this is a cos omega t. I'm taking magnitude at 1. This is the maximum value. This is the maximum value. This is at a 1. And this, suppose this is also at 1 same degree, sine omega t. Then how to write these two in the phasors? Okay. What I have told, always take the increasing or decreasing. Suppose these two are increasing or these two are decreasing. So in this, if you see, this is the increasing part of sine omega t, and this is the increasing part of cos omega t. If you see that uh, in terms of the angle when you're crossing right side angle, so this is the difference. Difference, it was already being said that cos omega t was lagging behind the sine omega t by 90 degree. Okay, means that when you are starting cos omega t, sine omega t was already there. Okay, when you take the cos omega t as a reference, suppose I am taking cos omega t as a reference, it means that it was sine omega t was here. Sine omega t was already leading with the angle of 90 degree. You can represent this in terms of phasor. Okay. Magnitude, because you cannot represent cos omega t here. So directly we represent in terms of magnitude. Suppose the cos omega t magnitude was 1 here. I have represented it here. Sine omega t magnitude we have already considered 1. So what will the net value? Net value will lie here somewhere. It was 1 square plus 1 square plus 2 times of 1 multiplied by 1 cos of 90 degree. It will cos 90 will be 0. It will come out to be 2. So how this angle will be 45 degree because is same. So this came out to be root 2 angle of 45 degree, the net value. Then what was the reference? Reference was cos omega t. So you can represent this in terms of cos omega t, in terms of like this, root 2 cos omega t plus 45 degree. Getting my point? Because you have already taken the cos as a reference, net is coming 45 degree leading. Okay, so you can represent this I net as root 2 cos omega t plus 45 degree. So leading lagging concept is such that ki how the phasors means how the values are changing with respect to another. You can directly see from the cos terms also, sin omega t terms also. Take one as a reference, convert into the phasor terms, then add or subtract the net value, then directly you can convert into the sin or omega t terms. Got my point? Any doubt? Okay. Let's move to the next question. Try to solve this part. This question I have kept related to the uh, power absorption. Okay. Just read the question and first, then try to solve. Then we will discuss. If you're facing any difficulty, just let me know in the chat box. Okay, I got one answer as a D. Okay. Anybody who's facing any difficulty to solve the question, take your time. Okay. I got one more answer as a B. Okay. It's good to see that you are guys are trying. Okay, let me give the some glimpse before solving this question. Stop solving and listen here. So, what kind of terms means what is important in terms of solving this question? First thing is what is a concept of real power, apparent power, apparent power. Third is the reactive power, and the real parts are two. One is the average term, second is the instantaneous value. Okay. So in the slides also, in the lectures also, you have seen that. Suppose this is the V. I'm representing in terms of Vm cos omega t. This Vm is the maximum value of the V, and the omega t is the omega is actually the frequency, and t is the particular time stamp. Particular time stamp. And I am representing as I is equal to Im cos omega t plus theta. Okay. So Im is the maximum value and theta. What about this theta? Let's see in terms of the phasor. Okay. What is saying that if you take the cos omega t as a reference, okay, in the phasors usually what happen, we represent in terms of the RMS value. And the RMS and maximum definition is RMS is equal to maximum by root 2. Okay. So this angle it will be become Vm by root 2 angle 0 degree. What it is? It is V. What about I? I is actually plus theta. Plus theta means anti-clockwise direction. It is leading. It is leading by V at an angle of theta. Okay. I'm not this taking the reference from here. It is leading with respect to voltage. So this is the theta value at which it is leading. And also what is the magnitude? It will be Im by root 2 angle theta. So this is the representation part that if you're taking the voltage as a reference, the current is actually leading kind of theta degree. So how to find out the values, this real power, apparent power, and the reactive power? Okay. Real power actually, if you're taking in the terms of average, it is actually VRMS, IRMS, cos of angle theta V minus theta I. Okay. What it means? VRMS is Vm by root 2, RMS is Im by root 2, cos of theta v. Theta v means what angle it is there. It means that cos omega t you can represent it as cos omega t plus 0 degree. Okay, value will remain same. So now currently it is at 0 degree. What at the angle of current? It is angle theta. Okay, so the real power, average power will become Vm Im by 2 cos of minus theta. Okay, what about the instantaneous power? Instantaneous power means you just multiply both terms. It will become Vm cos omega t multiplied by Im cos omega t plus theta. And this instantaneous power is represented at a particular time t. And put the values where you wanted to find. Suppose I wanted to find at a 1 second. Put the value of 1 here in the time t in the both terms. You will get the p at a particular time t or 1 second. If you wanted to find at the 2 second, you can put the value here as a 2 in both terms. You will get the p at a time 2. So this is the two concept with respect to the average power and instantaneous power. What about the apparent reactive power basically? Reactive power is same terms as we have seen in the average terms of the P. It is the Q average will be equal to Vrms, Irms. Here it becomes sine of theta V minus theta I. Okay. And what about the apparent power? Apparent power is the what you take the average value of that P average of square plus Q average of square. So this is the apparent power which is represented in terms of the S. The unit of power is the watt. Apparent power it is also watt. Reactive power it is the kVAR or VAR. Apparent power is VA basically. Okay, VA or kVA or MVA, whatever in terms in the magnitude terms it is defined. Okay, using this concept, let's try to solve this question. What is saying that what is asking? It is asking average power, not instantaneous power. Okay. So average power is basically we already defined that Vrms, Irms cos of theta V minus theta I. But here if you can see current is given, impedance is given, but the voltage is not given. Let's draw the circuit. Circuit is like this. Suppose this is the R and this is the minus J. So it was looking as a capacitor. This was the minus J3 and some current is coming here like this. Okay. So the drop or the power loss which happen across the resistor is the real power. And the what happened across the capacitor, it is actually the reactive power. Okay. And real power is also represented in terms of Irms square R because it will happen across the resistor only. What about the reactive power? Reactive power will be Irms square multiplied by Xc, whatever the magnitude of this. Okay, so this is actually the average power which will dissipate across the resistor or the capacitor. Okay, so let's go to the question with this formula. It is already saying that the R value is already given 4. What is the value of Irms? Irms is equal to I maximum by root 2. Maximum is given as 5, 5 by root 2. What will be the power average? It will become Irms square, 5 by root 2 of square multiplied by 4. What it comes out to be? 25 divided by 2 multiplied by 4. It will come out to be 50 watt. Got my point? So always remember how to find out the values of real power, and the real power is also two terms, average or instantaneous. What is asking? What is the reactive power, apparent power? Okay, got my point. So these are the three things you should remember that. And the reactive power is always consumed across the reactor or the capacitor. or capacitor absorbs lagging Q, delivers lagging Q, and inductor it's absorb lagging Q. Okay, lagging leading concept I will explain in the further slide. Just remember these concepts. Okay, and the formula itself. Any doubt in this? If you feel anything which is not understood by you, just let me know. Okay, I will share the slides. Share the slides, and the video will be always be shared. Okay, try to solve this question. Okay, I got one answer as A. Anybody who is facing difficulty in understanding this question, in the understanding part of it, clear your doubt before going or leaving this lecture. Okay, just let me know if you are facing any doubt in any point of time or any of the lecture slide. Last 1 minute. No? TK or Kelsey, just try to solve. I got one more answer as D. Okay. Okay. Always see that elements. It's not a resistive circuit. The elements are at a phase difference. In the inductor, the current lags the voltage, but in the capacitor, current leads the voltage. Okay, let me solve this question. And before solving, there are two concepts which I want you to tell. Suppose there is a one circuit and one capacitor is connected. And there is a one circuit where the purely inductor is connected, pure inductor is connected. Okay. And this is the current I which is going here, and this is the current I. And this is the voltages Vs and Vs. In the first circuit, this is the minus J, or you can directly say, suppose this is a capacitor C. So the what is the value of current in the first circuit? Current will be equal to Vs divided by JXC minus JXC. Okay. So this is the notation of impedance of this inductive circuit because Z is equal to R plus JXL minus JXC. Basically, R is equal to R plus JXL minus X. So if you see in this circuit, what is the magnitude it will come? It will come out to be Vs by Xc angle plus 90 degree. Why? This is a minus J. It means minus 90. When it will go in the numerator, it will become plus 90. What about in the second circuit? Second circuit is V divided by JXL. Magnitude, what it will come? It will come as Vs by XL angle of minus 90 degree. I'm taking Vs as a reference. Vs angle 0 degree. So let's draw in terms of the phasor. Vs angle 0 degree. I have taken the reference. What about the first circuit? Suppose this is the I1 and this is the I2. So if you see the I1 is actually the 90 degree leading. So it will come here. It will come like this. Okay? It is 90 degree. What is the magnitude? Magnitude is Vs by Xc. This is the RMS term. Vs is the RMS value. What about the second I2? This is the I1. I2, if you see, this is the lagging. So it will come here. This is actually the Vs by XL. So what in the inductor, basically, current lags voltage by 90 degree. And in the capacitor, current actually leads voltage by 90 degree. Got my point? These are the two things you should remember, and you can see from the circuit itself. Okay. So means current is when it's in which circuit it is actually leading or lagging. Okay. And if you see the angle difference between the inductor and the capacitor I1 and I2, it is actually 180 degree. What my point? The phase angles of both the circuits are not same. Of the resistor also, inductor also, and the capacitor also. Let's solve this question based upon this concept. Suppose I am taking this as a reference, this as a zero potential. Okay. So this will become V3 because why? Because there is a this is the circuit which I am considering here. So if you take this as a zero potential, this is at a zero. So this will become V3, this point, because there was no voltage drop in this line. Okay. So this become V3. Let's apply the KVL here. KVL at junction. Suppose this is junction J. Let's apply the KCL. Sorry, KCL at junction J. It means that summation of I is equal to 0. In the first tutorial session, I have explained, I have told you one trick that always assume current going outside of circuit, okay? Outside at junction, whatever the circuit is there. Suppose let's take this part. Suppose I take this line where I have assumed that it is zero potential and V3 is coming. So the current was going out. So that is fine. So current I have taken as I1 positive term. What about a V2? If I wanted to make that the current will go out of the circuit, it means that V2 is potential is inside. It means that what will happen? V3 minus V2 divided by J1 current will go out of this junction because V3 is at a higher potential. In this line, if you say this line plus V3 minus V1 divided by minus J will be equal to 0. Summation of I is equal to 0. I've assumed that always the current will go out of the junction. Let's solve. Put the values. V3, what is the value of V3? It's a 100 angle 120 degree minus V2. What is the angle of V2? V2 is 100 angle minus 120 degree and divided by J 1 plus what is the value of V3? V3 is 100 angle 120 degree minus V1. V1 is 100 angle 0 degree divided by minus J. Okay, equal to 0. Convert into the single magnitude and the angle terms. 100 120 divided by J1, what it become? 100 angle 120 minus 90, angle 30 degree minus 100 angle. This is a minus 90, it will go upper side, it will become plus 90 degree. It will minus 90 degree basically. So minus 20 minus 90, it will become minus 210 plus 100. This is a minus 90, so it will give above side, it will become 210. Angle minus 100 angle basically, and it will become plus 90 equal to 0. Now the thing is how to solve this. You can directly put in the calc and you will get the answer. Okay, this is one way, and second way is that you can convert into the rectangular terms and you can find it out the values. Okay, so when you get the answer, it will come out to be 173.2 angle minus 60 degree. Actually, the option one in amperes. First option is correct. So this is a simple way that you should assume that current is always going up, around the junction and also take one as a potential and zero potential and take one as a reference. Okay, you will find it out that at particular junction when you apply the KCL and always see that which is leading or lagging. In this question also that minus 60 is coming. It means that it is somewhere from some values it is lagging. So what is the reference in this whole slide? V1 was the reference. So when you draw these phasors also, how it will come out to be? It will come like this. 100 was taken as a reference and the V2 was actually lagging. So V2 will come here. V2. It was minus 120 lagging. When you see V3, it was actually leading in anti-clockwise direction by 120 degree. It is V3. Okay? This is balance voltage source. Got the point? Let's move to the next problem, which is also a very important problem to in an understanding point of view and quite lengthy as well. I will give few minutes for the understanding only. I will solve this question because one concept is missing, which is not being taught, but which was required for this question. Just read the question first. Okay, no, in answer wise, there will be no difference, Vishnu. What you are asking that what happens if we take the left side node as a zero potential? There will be no difference. Only the thing is, let me see here. V3 is this is the positive, this is the negative. When you take the this opposite side as a reference, suppose I am taking this as a zero potential, this become minus V3, minus V3. Okay, there will be no difference in the magnitude wise. Only the thing is negative it become, and that is already in all terms it will become negative. If we take the negative common as well, the answer will not create any effect on that. Getting my point? You can take anything as a reference, but always see that ki what is the potential coming in means series with that line. Okay, try to read this question. Yeah, yeah, that is true. That's why I was telling that one concept is missing here, that superposition principle, which I will explain. But you will get the this glimpse of these problems in the further assignments or further lectures, okay, where the network theorems will be taught. Just read the problem which I will solve, and just read the problem once. Take 1 minute to read. Okay, I hope you have read the question. I will solve the problem. Just you have to listen it here. Okay. This is the concept. There is a one thing which I wanted to show. That's why I have kept this question. If you see in this question, there are two voltage sources are there. That is at a 20 sine omega t. If you see that 20 sine 10t here, and this is the current term that is at a different frequency sine 5t. Okay. It means that they are at a different omega values. This is at a omega 1 and this is at a omega 2. What I have told in the phasor itself that omega value should be constant for drawing any phasor. That is a constant rotating term that is at a frequency of omega, which was very constant when the phasor got added or subtracted. Okay, but in this problem, omega 1 and omega 2 is there. Okay, you cannot directly solve this problem directly by applying KVL or KCL. Okay, so for solving this kind of problem, there is a one theorem called as superposition theorem, which is not needed here, but I wanted to show you the circuit which will happen when the frequency are not same. You cannot draw the phasor based upon that. Okay, you cannot directly convert this sine of 5t taking as a reference and then leading or lagging. You cannot apply that. They are the different rotating term. It is rotating at frequency of, if you see that omega is 5, it is rotating at a 5 by 2 pi radian means hertz, and this is the frequency here. If you see, it is a 10 by 2 pi. They are at a different frequencies. So if you see the superposition theorem, it says that it is applied basically at a linear circuit. Linear circuit means where the RLC components are there, not other than that, where the means time bearing or dependent sources or dependent loads are there. Okay. So it says that when the voltage sources are there, two voltage source or multiple voltage sources or current sources are there, you can take one source at a time, one source at a time, and make other sources as open circuit or short circuit. When open circuit, if the voltage source is there, if there is a other voltage source is there, short circuited, and open circuit if there is a current source. This is a thumbnail for solving this question. When you see in this question, if I take the voltage in the first step, suppose I'm taking the step 1, I'm considering only the case of voltage source as a into the circuit, 20 sine omega t. Then in this scenario, this 10 sines 5t will become open circuit. How the circuit will look like? Circuit will look like this. Okay, this is the 1 farad, and this circuit got open circuit, so no current will flow there. And this is the VC T, which is a VC1T. And also, when you find out the voltages or currents, just sum it up, VC1, VC2, based upon the multiple sources, you will get the final value. Okay, so this is the 20 sine 10t, and this is the 1 ohm. Now, if you see the circuit, there is only one frequency component. Only sine 10t is there. Now you can apply the phasors or you can use the single frequency component. Okay, so apply the voltage equation here, VC1. Apply means KVL, basically the voltage division principle. You will get the VC1. Let's talk about the step 2. Step 2, what I am doing, I am taking current source only, and I will short circuit the voltage source. Now how the circuit will look like? Circuit will look like this. 1 ohm, and this we have short circuited the voltage source, and this was the capacitor VC2T, and there were one resistor, and after that you have this current source. What was the value? It was, sorry, this was the inductor basically. This was the 1 Henry, and this was the 10 sine 5t. Okay. From here, you will be able to solve the value what is the coming across the VC2, across the capacitor. Now the step 3 is when you get the value of VC1 and the VC2, just add the values. In terms of the phasor, of course, VC1t plus VC2. You will get the final answer. Okay? Try to solve it at home because it's a lengthy problem. It will take time to solve. Okay, I have to give the concept of the other problems as well. Just remember that how to solve this problem. The answer will come out to be option A. Okay, there you will get the two center. If you see in the VCT also, omega 1 and omega 2 is there. From the equation itself, one come as a 10. One component omega t will come out to be 5, and this will be the 10, or vice versa, or reverse will be there. Okay, so this is the way to solve this kind of problem when there is a two frequency components are there. Okay, let's move to the next problem. Try to solve this problem. Solve that question at home. If you feel doubt in at any point, just we will discuss it in the lecture next tutorial session. Take 1-2 minutes only to solve this problem because I have to cover other parts as well. Anyone? Okay, I got one answer as a 250 watt. Okay, fine. Okay, see here. Stop solving. Just listen what concept I am giving here. Okay. So what I have told the about the instantaneous power. Instantaneous power is equal to VT multiplied by IT. Okay. So you wanted to find the power at a 1 second, just multiply both values and put the values of one second, and you will get the answer. What about the average power? Average power is basically it is 0 to t p instantaneous of t d omega t basically. So this is actually the average value, average out to of the instantaneous value. Okay. So there is a one thing is there when you multiply the DC term of any voltage or current with the other any frequency term, it will become zero in the average form. You can see the derivation of the average power in the from some book or somewhere, and this concept will come into the picture that when you multiply a DC term with a frequency term or sinusoidal or cos term, it will become zero. And when you multiply the two different frequency terms also, it will instantaneous, that average will become zero. Only thing it will come into the picture, the same frequency term will be the multiplied. If we are multiplying omega 1 with the omega 1 term, it will not be equal to 0. Maybe 0, but not necessary. Or omega 2 multiplied by omega 2. Okay. So same concept if you apply here also. VT, there are means different frequency terms are there in the IT. Here the omega frequency is there, and here omega is there, and here 3 omega, here 5 omega is there. So what non-zero term will come into the picture? When you multiply this omega with the 3 omega or 5 omega, it will become 0. So let's try to find out what is the value of VTIT basically. VTIT PT, instantaneous power. Then instantaneous power will become 100 sine omega t multiplied by 10 sine omega t minus 60 degree plus 100 sine omega t multiplied by 2 sine 3 omega t plus 100 sine omega t multiplied by 5 sine 5 omega t. When you take the average of it means integrating with respect to t, p instantaneous t, what terms will become 0? This term, let me take the another pen, let me take the blue here. So that this term, it will become 0. Similarly with this term will also become 0 because they are multiplying with the different frequency vector. What about this term? This is actually the 0 to t 100 multiplied by 10, that is the 1000, and sine omega t and sine omega t minus 60 degree with respect to d omega t. When you take find it out from the values and all, so this is basically the one term, and the one term is there in the VTIT. What I have told the in that part, VRMS IRMS cos of theta V minus theta I is the average value. Okay, because there are two terms of value remaining, 100 sin omega t and 10 sin omega t. What is the VRMS value? That is the 100 by root 2. I, what is the remaining? 10 by root 2. What is the cos theta v? Theta v is there taken as a reference, so it was 0 minus of 60 degree. When you solve this, it will come out to be 1000 divided by 2 multiplied by cos 60. Cos 60 will become half. It will come out to be 250. Got the thing? Any doubt in this? Just remember that when you multiplying the DC with some frequency, it will become zero, and two different frequency term in the instantaneous values, then it will become zero when you're taking the average. If you got the answer, try to solve this. This is on the similar pattern. Try to solve this problem. Try to solve it faster so that we can move to the mutual and a self-inductance part, which will be helpful to solve the assignment 5. Use that concept. DC multiplied by one frequency is zero, and the if you're multiplying two different frequency terms also, that average will be zero. Whether it is cos or sine, that doesn't matter. Anybody? Okay, let me give the solution for this. Just stop solving, just listen here. So if you see in the VT, if you see in the VT and the IT, there are two terms are there. VT is represented as 5 minus 10 cos of omega t plus 60 degree. Okay, so this is actually the DC term and this term is the AC term. Similarly, if you see in the IT also, it was represented as 5 plus x times of cos omega t. This is actually the DC and this is the actually AC term. Got the point? What I have told, if you multiply DC with some frequency term, the average of that term will be equal to 0. So if you find out the instantaneous value, what the terms will come out to be? That is the 5 multiplied by 5, that also will be equal to 0. And similarly, if you see in the terms of, sorry, DC term will exist, okay? DC will not be equal to 0. DC multiplied by DC will not be equal to 0, okay? And if you see that this is the 5, one term will be 5 multiplied by x cos t, cos omega t. This will become 0. Its average will become 0. And similarly, if you see 5 multiplied by minus 10 cos omega t plus 60 degree, means 5 of current and minus t of the voltage, it always average will be also will be equal to 0. What term will come into the picture? There is only two terms will be picture. That is the 5 multiplied by 5 in the instantaneous term. That is the 5 multiplied by pt. And one more term minus 10 times of x multiplied by cos omega t plus 60 degree and cos omega t. Getting my point? So what about the average? Just take it with respect to t d omega t. If you take this also t with respect to d omega t. If you see the DC part, it is at a certain frequency. Okay, so this, if you means the solve with respect to d omega t, it will also come out to be 25 only, because the DC term when you're taking the average value, it's a just a area. Okay, multiplying the two values only. This is the only the DC values. But when you take the average of this, okay, minus 10 cos omega t plus 60 degree, that I have already told that that will become vrms irms cos theta v minus theta I. You can directly use that because there is only two cos terms are there, volt of one voltage of the current. That will become 10 by root 2 multiplied by x by root 2 cos of theta v minus theta I, that is cos 60 degree. Okay, it will come out to be, let me solve here, let me solve it here. It will come out to be 25 minus 10 times of x divided by 2 multiplied by 2. Okay. It is given in the question that the average power is 0. When you solve it, it will be come out to be x is equal to 10. Because this is a 4. 4 become this. When you cross it, it will become 2.5 and x will become 10. So this is the correct answer. Okay. This is the one concept that to see that when you're multiplying DC to DC term, it will non-zero, and when you're multiplying DC with the some frequency term, it will become zero. Try to solve this problem. This is related to the mutual and the self-inductance. If you have seen the slides or you have seen the lecture, then you can solve it by easily. If you don't know the self-inductance or the mutual inductance, just let me know in the chat box, or you can open your mic and let me know. Then I will give you the concept beforehand. Anyone who is not able to understand the self-inductance, mutual inductance, just let me know. This is the dotted terms for the mutual inductance basically. This is the dots. And 4 Henry, 4 Henry, 4 Henry, this 4 Henry, 4 Henry, 4 Henry, these are the self-inductance, and 2H, 1H, 1H is the mutual inductance it between the two coils. If you're facing any doubt, just let me know. Okay, there was one question being asked that previous value, the 100 radian is not used. Why? Uh, there is a one concept which I can go in explaining, but I hope you should solve it by yourself. That is the when you calculate the value of PT, that is the instantaneous power, when you average it, basically you are averaging with respect to the time. Okay, time is time frame, whatever the cycle is you are using. Suppose the sine terms are there, sine term cycle or cos term cycle. Okay, let me give you some glimpse of that. Uh, uh, Suppose you're like this. Suppose this is the one DC term is there. DC is suppose this is X, and one term is there sine cos term. Suppose this is the cos term, and this is the 90, and this is somewhere 180 degree. When you multiply both, when you multiply both, this multiply DC with the positive term, some magnitude increment will be there. When you multiply negative term, it will go into the negative value. Okay, so basically. So when you average it, it means that the area here, area in between, it will become zero. Okay. So that's why I was saying that the positive term when you multiply it by DC and when you take the average, the area will become zero. So what about the DC? If you take the DC component, suppose this is the DC X and DC Y. When you're taking with respect to the time T, okay, average. Basically, I'm talking about the average. Let me finish that, Arma. After that, I will take your question. When you're taking the DC term, that is the X and Y, what about the average value will be 1 by T, 0 to T, DC term is X, DC term is Y, multiplied by d omega T. That was the thing. When you're taking the average, time term was already there, 1 by T. And when you take the area, it will become XY, d omega T will become T. When you see in the question that XY term will ambly come into the picture. That's why I have not taken the omega t term. Because the t was already there in the denominator, it will cancel out the d omega t term when you take the area or take the integration with respect to 0 to t. Got the point? That's why I have just multiplied the DC term and not taken the omega n. Okay. Okay. Let me give the solution for this question, but before that, I wanted to explain few things. We should take care of few things. So there are two inductances are there. That is one is the mutual and the second is the self. Okay. The thing is, suppose I am taking the two coils. Suppose I have taken these two coils. This is transformer coils. What happens that when you apply some voltage here, some AC voltage here, and some Arava, you wanted to ask anything? You can open your mic and ask. Okay. So suppose this is the one voltage source here and voltage source here. Okay. Arava, you wanted to ask anything? You're raising your hand or okay. So suppose the current I1 is coming from here and I2 is coming from here. So what we have studied is that there is a phi which come into the picture which is multiplied by the inductance. Suppose this is the L1 inductance here and L2 inductance here. So it will be equal to phi 1 is equal to L1I and similarly phi 2 will be equal to L2 times of I. It means that current is actually responsible for creating the flux. How much flux will be created? It depends upon the property of the inductor. Property of the inductor is what? This is the inductance. Okay. So based upon that, the current will define the what is the magnetic flux which will be created into the circuit, and that is on the based upon the property of that inductor. That is the L1 value. Okay. So the flux will be created. Flux will flow like this somewhere, and some flux will be flowing like this. So some flux will link outside of that also. Suppose let me take the another pen. Some flux will be linking here as well. Okay, that through the I2 current. So from the second term, sub flux will link to the first coil. That is the mutual flux. From the property of the second circuit, some flux is being linked to the first circuit. That is the mutual part. And what was happening inside of the circuit that by the self, it was the self inductance. Okay. The flux basically, the flux, mutual flux, phi m here, phi s here, phi s self inductance, self fluxes, phi s1, phi s2. And the some part will be the leakage as well. It means that some coil, suppose this is the one coil, some will be linked here. Let me take one pen here. So some flux will be moving from here. So that was the self, and some will be, oh sorry, some will be coming from the somewhere else as well. Suppose some is the coming from the opposite circuit. So that is the mutual. And one flux will be come from the somewhere else as well. Suppose let me take here. So some flux will move here and nowhere it is the any circuit which is being linked. So it will become leakage, which was not utilized basically. Okay. So the overall term, if you see in the picture, how it will represented like this. So the phi net, how it will come? It will become phi, which was the self, plus phi m, what is coming from the opposite side, and also the minus the phi leakage. This is the net flux which is appearing across the one inductor. Okay. So, but this polarity, this phi m, what happens that there is a one direction. Suppose the flux is moving in this direction, and mutual flux is coming in from the opposite direction. So then it will try to reduce the self flux of that circuit. Okay, so it here the negative term will come. So based upon the polarity being used, the flux of the particular circuit will rise or fall. That is actually the mutually from the opposite circuit. And the leakage parties don't have any physical significance into the circuit. It just to means not if it is not linking with the other circuit, then it have no use. Okay. So for representation of this, LS we use for the representation of the self-inductance of a circuit, and we use the LM term to represent the mutual inductance of any circuit. And if two coils, suppose this is the two coils, when they are in the series, suppose, and this is the dot polarity here, it means that the current which is entering here, okay, the same current means here in this coil also it will enter in the positive means dotted terminal. It means that the flux mutually will be added up. Try to see from the flux direction also. When you suppose this is the palm, um, and when you try to see from the right hand thumb rule or something, you see the current, the flux direction you can see, and after that in the opposite circuit also how it is linking. Okay. So in this term, the phi mutual will be equal to phi 1 plus phi 2, phi m1, phi 1 plus phi 2 basically, whatever the component. Suppose the phi m1 component, phi m2 component. Suppose the dotted point is in opposite direction. It means that the current which is entering the positive terminal is actually leaving from the opposite side, opposite series circuit. It means that the phi m will be equal to whatever the linkage was there. It is like this. So it is reducing basically. So the phi actually the L effective usually the equation is like this: L1 plus L2 minus 2m or plus 2m. Plus 2m basically when it is adding, minus when you. And what about the self? Self of one inductance is equal to L1 plus minus m, or and basically L self of 2 is equal to L2 plus minus m. This is the net self or net self of 2 with the mutual as well. If the leakage is also there, you should subtract. Getting my point? When the fluxes are getting added up, the mutual inductance will come into the positive part. When they are reducing each other, then it will come into the negative part. So in this question, if you see, suppose in this question, if you see, the current is entering from here, okay, leaving from this dotted terminal, but entering into the dotted terminal in this. Suppose this is L1, this is L2, and this is L3. Okay. So if I consider L1 and L2, what is the L effective it come? L effective will come like this: L1 plus L2, L1 is L4, L1 plus L2 minus 2m. Why? Because if the dotted terminal one side current is leaving and other inductance it is entering. So it will become minus times of 2 times of m. M is 2. That is a 2 Henry. It will come out to be 4. If you take the L2 and L3, similarly, L effective will come out to be 4 plus 4 minus 2 times of 1, it will come out to be 6. If you take the L3 and L1, because the mutually it is happening in between the each coil, L effective will become 4 plus 4 minus 2 times of 1. It will come out to be 6. Got the point? Any doubt? Sorry, L2 and L3. L effective, L2 and L3. If you see the L2, it is entering. L3 is also entering. So it is a positive basically. 4 plus 4, 8 plus 10. L3, L1, L3 and L1. If you see here, it is out and this is in. It is negative 6. Okay. So now the thing is what the net will come out to be. Net, if you see here, the L effective basically. L1 means when you add it up, L1, these are actually the particular self values because the L1, L2 will come out into all the pictures. L1 plus L2 plus L3, that is the overall effective. I'm taking here the effective if I take the only two inductance only. L3 effect is not there. Plus minus 2 times of M1 plus M2 plus M3. Similarly, L1, L2, L3 will come out to be 4 plus 4 plus 4 plus 2 times of, in the first circuit it was subtracting, that is the minus 2 times of 2. L2 and L3 it is adding basically 2 times of 1. If you see in the L1 and L3 it is subtracting basically with 2 multiplied by 4. When you add it up, what is coming out to be 12 minus 4 plus 2 minus 8. Okay, so this will cancel out and it will come out to be 2 Henry. This is the L effective only when we consider the two inductance L1 and L2. L3 is neglected. L2 and L3 when I have considered, then like that. When you take the all the inductance in the one circuit at a time, then L1 plus L2 plus L3 plus minus 2 times of M1, M2, M3 kind of. Let's move to the other problem. Uh, See from here. So there is a one term called coupling, magnetic coupling. It means that how much coupled the two circuits are there. Okay, it means that how the linkage of mutual fluxes are between the two inductances. That is measured in terms of K. Okay, K is basically equal to mutual inductance divided by L1 and L2. It means that the mutual inductance depend upon the K value and the L1 and L2 values as well. Okay, but the K value usually differs from the 0 to 1 range. Okay, that same range if you see, if you put this value here, the M by L1, L2 in between this 0, so M will be less than or basically equal to root L1, L2, D option. So remember that what is the magnetic coupling is there, and magnetic coupling is basically the how the mutual fluxes are being linked into the two circuits, two inductances basically. That is the strongness of the coupling. Okay. One more question is there, which is the last problem. Basically this. Try to see here. I will solve, and after that you can solve at home. And the question is saying there is a two identical coupled coil is there, which are connected in series. It means that connected in series like this. This is L1 and this is L2. The major inductors for the two possible series connection are three means L effective are two terms means 380 it is there or 240 it is possible. It means that there's a two conditions are there, two possible ways. Means suppose the L1 and L2 are like this and polarities are like this when you edit additive polarity, or the possibility is like this. Suppose dot is here, dot is here. So in this case, the L effective will come out to be L1 plus L2 plus times of 2. In this, it will come out to be L1 plus L2 minus 2N. But if you see in the question itself, it is saying two identical coupled inductor. It means the L is constant. So here what it will become 2L plus 2M. Here also 2L minus 2M. So the two possible values are 2L plus 2M is equal to 380 because it was higher. 2L minus 2M value is 240. So here you will get the L plus M value as 190, and here you will get L minus M value as 120. This is the equation 1. This is the equation 2. When you solve these two equations, let me solve here itself. When you solve these two equations, add both equations, you will get 2L. It will come out to be 9 to 11, 310. L will come out to be something like this 2, 1, 2, 1, 2, 5, 10, and 2, 5, 10. Okay. So this is the L value. And M value, what will come out to be? M value will be equal to 155 minus 120. It will come out to be 35 basically. Because this is the only two equations are there, so only one value will be possible for L, one value will be possible for M. So it will come out to be 35. Okay. So this is the concepts of mutual and self-inductance, and also we have seen the how to do the phasor analysis and all. Okay. So few questions I have not solved. This is the unsolved problems. So basically, I am just giving the answers. You can solve at home. We will discuss in the next tutorial session. I am giving just answer part. Okay. Here you can solve it. And few problems like this problem was there. You can solve. And this problem, this is basically the finding of the RMS value. And this also finding of the some phasor value. And this was a easier problem. Okay. So that's all for the today's lecture. I hope you have got the few glimpse of that. Try to solve it, and if there is a one problem, some problem remains, so we will discuss in the further tutorial session itself. Okay, on the Tuesday. Okay, or you can discuss with the some other TAs as well. That is no problem with that. Okay, any doubt or any suggestion you wanted to give?
Yes, sir. Only one doubt, sir.
Yeah,
That V1, V2, V3, the three values are given, right? 100 at angle 0 and 100 minus 120.
yeah.
100 angle 120. In that problem, suppose you are taking the reference in the left side, then
Yeah.
how to solve this, sir?
Let's see. Suppose I'm taking the reference here. Let me take the circuit. So I will take this one sample circuit basically. Suppose I have taken the this Z1 was there and this was the this and this was the Z2 and this was something like this circuit was there. Okay, this was the positive, negative, positive, negative, positive, negative. I have taken the left right side reference. So suppose I am taking the left side reference. So it what it will become. Suppose this was the VS1, VS2, VS3. Suppose I am taking this at a zero potential and this will become minus VS1. Okay, so current was going like this. So what I have told, the current you should always take that leaving from that junction. So but here in this junction, it is coming into the junction. It means that you should take the minus side plus. If you wanted to take the current from this junction out, it means that the minus VS1 is at a higher potential. Okay. So the minus VS1 minus plus VS2 divided by Z2 will be the current which is flowing in this circuit. So let me take this another pin. So in this circuit, the current will flow. I've assumed that it is going out. So it will be minus Vs1 minus of minus Vs2 divided by Z2 plus minus Vs1 minus of minus Vs2. Suppose this is 3 basically. Vs3 divided by Z. If you see this part, minus I plus minus Vs1 plus Vs2 divided by Z2 plus minus Vs1 plus Vs2 Vs3 basically Z3 is equal to 0. This is the same equation, but the negative is multiplied in the all the parts. There is no effect in the equation itself. If you see the equation itself here in this part, there is a positive terms of were there. Here it was positive, here it is negative. But if you see in this part, in this, only thing is that it is negative multiplied. So there is a no difference between the answers. Only difference is the negative term. It will come in the equation part only. Got the point?
Okay, sir.
Uh, okay, thank you so much. Thank you for joining. So that's it. That's it from my side. So we will meet on the next tutorial session. Okay.